Hey guys, Mr. Wilson here. Today we are going to talk about multiplication properties of exponents. At the end of this video, you should be able to accurately use multiplication properties of exponents to simplify exponential expressions. Okay, so let's start off. We have a problem. We have 3 to the 4th times 3 to the 5th. Okay, 3 to the 4th power times 3 to the 5th power. We're going to rewrite this. Okay, I'm going to rewrite 3 to the 4th. Okay, and that's just 3 times 3 times 3 times 3. 3 to the 4th. I want to rewrite 3 to the 5th, which is 3 5 times. Okay. So basically, this is 1, 2, 3, 4, 5, 6, 7, 8, 9 threes multiplied together. So another way of writing this would be 3 to the 9th. Okay, here's the rule or shortcut. The shortcut is that now, instead of doing anything really intricate, if we are able to just multiply or add the exponents. 3 to the 4th plus 5 is 3 to the 9th, or I don't know what that number is. 3 to the 9th. 3 to the 9th. Yeah. I don't think that's important. So the shortcut is to add exponents. Alright. So, here's the rule though. Bases must be the same to use this property. Notice that this is 3 to the 4th and 3 to the 5th. We would not have been able to do this with 2 to the 4th and 3 to the 5th. Okay? And the operation between the two expressions must be multiplication. Alright, so let's go through some sample problems, because that is the big idea, the learning target. We should be able to do this, and now we're going through some problems so we can see the different ways that it shows up. So we have h to the 5th times h to the 2nd. Okay, same base, multiplication, so we can rewrite this as h to the 5 plus 2, or h to the 7th power. Okay, works with numbers as well. We have 2 to the 7th times 2 to the negative 3rd. So essentially what we're doing, we have negative 3 plus 7, adding those together. And so we have 2 to the 4th. If we wanted to, we can simplify that to give us 16. Okay, now number 3, we have b to the 4th and c to the 7th. Okay, notice our bases are not the same. So if we write this, then really we can just keep them like this. Okay, you can't combine those exponents because our bases aren't the same. Number 4, we have m to the negative 9th, m to the 5th, m to the negative 2nd, so negative 9 plus 5 minus 2, adding all those numbers together. And so what we have is m to the negative 6th. Okay, now remember that in a simplified answer, we will never have a negative exponent. So to make sure we move that to the denominator, 1 over m to the 6th is our answer. Okay. Number 5, we have 6 to the 8th and 6 to the negative 8th, so we add those together, we get 6 to the 0 power. Remember, anything to the 0 power is 1. Number 6, we have p to the 8th plus p to the 3rd. Okay, remember this is plus, so we can't simplify that. And so really we're stuck with what we were given. It's as simplified as it got. Alright, let's step up the complexity just a little bit here. Number 7, we have 2 into the 5th times 3 into the negative 2nd. Alright, so here what I want you to do, just like we did when we were multiplying scientific notation is I want you to group this in a way that's going to be beneficial for us. And so the way that helps us the most is to put numbers that are alike together. I'm going to group 2 and 3, and then I'm going to group into the fifth times into the negative second. Okay, and the reason that we can do this is because it's all multiplication, and so multiplication in any order stays the same. And then we're also doing this because we have the same basis. We're putting the same basis together. So 2 times 3. No, the bases aren't the same, but we know how to multiply numbers. 2 and 3, 6. Okay, here we have into the fifth and into the negative second. So into the fifth minus 2 is into the third. So 8, no parentheses, but still we're going to group in a way that helps us. 6 times 3 times 2, taking all my numbers and putting them together. Then I'm going to take all my y's and put them together. Okay, notice what I did with this last y. Okay, and I would recommend that you guys do this, especially until you get used to using these exponents. Any number has an exponent. Remember that exponent's 1. Okay, and so I want to make sure that when I write this down, especially if I've dealt with a lot of numbers, that I write this 1 here so I can remember that I need to add that to this exponent. So 6 times 3, 18 times 2, 36. Got that down. Then I have y, 3 plus 4 plus 1. Y to the 8th. Okay. Number 9. Okay, you'll see that we have C, D, and C, so I want to group these C's together. C to the 4th minus 8, D to the 3rd. So 4 minus 8 is negative 4, D to the 3rd. And so I have a negative exponent. I want to move that to the denominator. Remember, so that the exponent becomes positive. So we have D to the 3rd, it stays in the numerator, over C to the 4th. Alright. Alright. I will do number 12, but I want you guys to do number 10 and number 11. Okay, number 12, I'm doing this just because it's a fraction and I think it's the only one that we see here. I'm going to handle the numerator and the denominator. Okay, notice that in the numerator they're both k's, so k times k to the negative 3rd. Remember, that's k to the 1st times k to the negative 3rd, so I'm going to subtract 3. In the denominator I have n to the negative 7th times n to the 4th, and so I'll have k to the negative 2nd over n to the negative 3rd. Okay, negative exponents means they need to move, right? They don't like where they're at, and so what I have is n to the 3rd over k squared. Okay, remember to do 10 and 11. Hopefully you saw enough examples of how that rule worked. Alright, see ya. Alright guys, so here we're taking these multiplication rules with the scientific notation. We have this problem 2.5 times 10 to the 8th times 6 times 10 to the 3rd. And with scientific notation, this is what we'll do. Remember, we can kind of separate these. We're going to separate these and organize them in a way that is helpful for us. So we're going to multiply the a values together. That's 2.5 and 6. And then we're going to add the exponents. Okay, remember, because when we're multiplying, we're adding the exponents. And then we're going to make sure the numbers in scientific notation. So when we multiply these numbers together, we actually get 6 times 2.5, which is 15. Times 10 to the 11th, because 8 plus 3. Okay. This isn't in scientific notation, so what we'll do is we'll move it to the decimal so that it is in scientific notation. We'll get 1.5 times 10 to the, not 11th now because we actually moved it to the left once. This says move right 11 times. Since we moved left once, it's going to say move right 12 times. Okay, so 1.5 times 10 to the 12th. Okay, so you can try this next one out. I'll work with you. 9 times 7, which is 63. 10 to the 6, 10 squared is 10 to the negative 4th. We'll move this to the left one. So we'll have 6.3 times 10 to the negative 3. Because this will say move left 4 times, and then we move left, and it says, okay, we'll move left 3 more times. Okay. Alright. This last problem, you can pause it and see if you can get this. I'll go right now. Okay. Remember that it's always a good idea to group and simplify before you plug in your numbers or your values. So I'm going to group these, negative 3 times 2 times 5, all the numbers. I'm going to group all the m's together, and that will give me m to the 4th, m to the negative 6. Then I'm going to get the n, which should be by itself, to the 3rd. And now I'm just going to multiply all these together. 5 times negative 3 is negative 15, times 2 is 30. Sorry, negative 30. M to the 4 minus 6 is m to the negative 2, and then n cubed. Cannot forget that our rules are we cannot have negative exponents, so we'll take this negative exponent, we'll move it to the denominator, and everything else is fine. Remember, negative 30 is okay where it's at because 30 is not an exponent. Okay, and so the exponent for negative 30 is 1. That exponent is positive and stays where it's at. Okay, and so here are adding those, or using those multiplication rules with scientific notation and evaluating functions. Okay guys, see ya.